Hello, welcome to Nanotechnology and Material Science. Today I'll be sharing with you about smart materials are design materials that have one or more properties that can be significantly changed in a controlled fashion by external stimuli, such as stress, temperature, electric, or magnetic field. We have a few examples to show you.
I'm gonna show you what is thermochromic dyes. These two beakers are filled with thermochromic dyes, and when you heat up the solution, they start to change into white or colorless. But in this case, it will be white. This dyes is also called Leuco dyes. This dyes is micro-encapsulated into tiny droplets. They are only about 3 to 5 microns in size, which prevent them from reacting or being damaged by other chemicals. These dyes can be blended into other colors to have two-tone effect. This may sound a bit magical, but there is some basic science behind it. You can see capsules containing a colorant, an organic acid, and a solvent. At low temperature, the solvent remains in solid state, keeping the colorants and acid in close proximity to each other. As a result, they reflect light and create color. As the solvent warms, the colorants and acid separates and there is no visible color, which in turn explodes. When you paint onto something, let it cool down to room temperature to revert to its original color. Next example, we have thermochromic sheet. It is the same concept as Leuco dyes, but in this case, it is in a solid state. This type of material have been used on many consumer applications. Example, we have the battery. As you all remember, this specific battery can check on how many volts is left by pressing the top and bottom part together, and it will light up to a certain point. Next consumer product we have is the thermometer. This thermometer have been installed with multiple thermochromic sheets. It changes to specific colors when it heats with a range of temperature. As you can see, smart materials also help and improve our ways of living.
I'm going to share with you all about piezoelectric. What is piezoelectric? Piezoelectricity is the electric charge that accumulates within certain solid materials to produce electricity resulting from a pressure. A modern weapon we all know using piezoelectric is the RPG-7. How it works. When you press the trigger, it generates electricity and the trigger the ignition of the booster to propel the grenade. All this in less than a second. Other applications also using piezoelectricity include lighters, buzzers. I hope you have a better understanding about piezoelectricity.
For me, I'm sharing on super absorbent polymer. These are the few applications. This polymer is from a diaper which you can purchase anywhere. This polymer absorbs aqueous solutions through hydrogen bonding with water molecules. In deionized and distilled water, it is able to absorb 500 times its weight, which is about 30 to 60 times its own volume. It can take up to 99.9% of liquid, but when put into a 0.9% saline solution, the absorbance level drops to around 50 times its weight. The presence of valence cations in the solution impedes the polymer's ability to bond with the water molecule. If you heat the polymer at a very high temperature and let all the water evaporate,
one eternity later,
it will return back to either fiber or powder form. Another example we have is the water baby. They started small, but the rate of absorbing water is quite slow.
the next day.
Now this beaker full of water babies are filled with water. Now we are going to expel the water. In this process, salt was used to hasten up the expulsion rate of the water.
6 hours later,
The water babies have expelled 3/4 or more of the water they have absorbed, and these are the results. Left side, fully absorbed. Middle, expelled 3/4 amount of water. Right side, totally expelled all water. Wow, it's mind-blowing, right?
Hope you have a better understanding what is smart material. See you all soon.